I'm actually a PhD in physics guy, right? I'm not a computer scientist. I don't have a computer science degree. I did a PhD in theoretical physics, and I was working in academia, working in trying to use mathematical methods to try and understand nature, right? Somewhere, after about 5-6 years in academia, where I've used these mathematical methods to solve different set of problems, I found a job opportunity at a financial firm, at a hedge fund. Now, I don't know if any of you have heard of hedge funds, but I'm sure most of you would have heard of something called mutual funds. Mutual funds is a way people invest money. It's a collective pool. There is a manager who collects your money, and with this collective pool of money, they select a set of stocks and invest in these stocks. Hedge fund is similar to that, except these guys are willing to take much more risky strategies. They are willing to look at any time frame. So in a typical mutual fund, what happens is that a mutual fund manager holds a particular stock for maybe a year or two, in many cases, up to a decade if the company is a great company. What happens with hedge funds is that a hedge fund manager is more keen on looking at what is the current trend in the market, identifying the current trend in market with using any of the tools available, and get in and out of stocks. So sometimes hedge fund managers are often in a trade for just a few seconds, right? They identify that there is a large order that's going to come in, and they go in, they buy ahead of that order, and after the price moves up by a small amount, they get up, and they keep doing this over and over again. And this is what intraday traders do. And there are other hedge fund managers who do different other kinds of strategies. The key aspect in all of these strategies is the math. Now, what I realized is that this underlying set of mathematical techniques that these funds were using were actually very similar to the kind of mathematical techniques I was using when I was in academia, as some of the techniques I had learned during my PhD in physics, right? I was part of the fund for about 10 years, and I moved to India about 7 years back in 2014. And I realized that the set of techniques that we were using, both in the hedge fund and prior to that in academia, these are set of techniques. I had to read multiple papers and look at those papers and see what kind of codes need to be written. And often you had to search on the web to see if someone else has written this code and put it out in public domain. You get that code and try to solve these problems, right? This is the way I used to solve these problems. But what I realized in the early part of this decade, all of these set of techniques, had now come into one common umbrella, which they called as data science. And this particular set of techniques were now being taught as a separate independent field, right? These were set of techniques that were put together by experts in very different domains, right? And these set of techniques were created by people for solving their own set of problems. Some of these techniques, the earliest of these techniques were created by Isaac Newton, right? When he invented calculus, around the time when there was another pandemic and another lockdown, right? This was the plague 400 years back. And there are other set of techniques which were created as recently as 10 years back, right? All of these techniques now come under this common umbrella called data science. And what I have found is that if you have a reasonable understanding of math, and more importantly, if you are willing to learn, always willing to learn and always willing to put in the hard work, it's very easy to get into this field, right? This field is a lot of fun. It's a lot of fun because what you see is that you have this pre-written set of hooked algorithms, right? and these algorithms are readily available. Depending on what domain you're working on, you will find that you'll be able to pick some of these techniques, apply on that particular domain, and immediately get results that the business finds interesting, right? And so this is one of the main reasons why AI or machine learning or data science per se is considered as one of the hottest areas in the current decade. In fact, a lot of people claim, you would have heard the statements from other industry experts, that we are going through sort of an industrial revolution 4.0, right? The original industrial revolution is the one that we all learned about in history textbooks in 1700s. And this particular industrial revolution started because of, mainly because of the steam engine, right? Mechanization is what resulted in that first industrial revolution. Industrial Revolution 2.2 is something that sort of started on, about 150 years back, when electricity came in, and which enabled mass production, right? And this completely changed the world again. People who were relying on old skill sets had to reinvent and relearn the new skill set and acknowledge that the life around them had changed. About 100 years later was Industrial Revolution 3.0. And I clearly remember this one that sort of tells about my vintage, is when personal computers came about. When personal computers came about, that again fundamentally shook the world around us, right? People who didn't realize that the world around them was changing were very soon finding themselves out of jobs. And but at the same time, tons and tons of new jobs were created for people who are well versed with the current skill set. There's new technologies that were emerging. What I believe, and what a lot of other people believe, is that we are in the time period of Industrial Revolution 4.2, where data science is driving these things, and new set of technologies are emerging, and which is creating unimaginable amount of progress around us, and wealth around us, and benefits around us, right? And people who are seeing this and who are quickly adapting to this new industrial revolution that's happening around us will end up doing very well in career, right? And so this is, you guys are early in the early stages of your career, and you should be aware of what's happening around you. Now, why is this excitement about data science, and why am I claiming that there is Industrial Revolution 4.0? Well, there are two pictures that I can show, which shows why there is reason for this excitement. So the picture that you're seeing on the screen is a picture from the year about 15 years back, in somewhere taken in Europe. There was some political rally happening, right? And here is another picture, which is taken just about 7-8 years later. Again, Europe, again another political rally happening, and you see a massive difference. The difference is how information is being recorded. Everyone has a smartphone. All of us are recording information. As on a day-to-day basis, we are generating data, and every single company around us are realizing that we all are creating data, and we are all our source of data. And this Industrial Revolution 4.0 is happening precisely because not just there is massive availability of data, but there is availability of infrastructure, and people are realizing that there are methodologies available which can allow people to monetize data, right? And that is the reason for this Industrial Revolution 4.0. Let me first start off by clarifying this jargon. Right? Many of us have heard of these terms, right? Machine learning, we have heard of predictive analytics, data mining, we have heard of big data analytics, and then this big daddy of all, data science, right? And often, these terms are sometimes used interchangeably, and it can be confusing for people as to what each of them means. And I once got to fault the media for it, because often the media and reporters sort of use these terms interchangeably. But there is subtle difference between these terms, and I will try to clarify these terms. Right? These are all terms that came up to indicate this field that has sort of evolved over the last decade or 2 decades. It's where you have this set of algorithms that are working on large volumes of data, and it's being used to solve important business problems, right? An easy way to understand this is through this chart, this Venn diagram, so to speak, which sort of shows this whole area of data science. There are two big subsets in this. This subset is a subset that has sort of existed even before the current excitement about machine learning and AI came about. This is an area where people are looking at data per se and trying to understand patterns in the data and trying to visualize data and communicate this data back to business. Right, business analytics or business intelligence are areas that have been that are words that have been commonly used for, I would say, almost like 3 decades now. And this analysis used to be largely done on Excel sheets. You're looking at data and you're trying to understand patterns that are there in data. The recent excitement on ML machine learning per se and machine learning and AI is actually another sub-branch that sort of developed alongside, where there are these 3 terms that you would have heard in either newspaper articles or job reports or whatever. You would have heard terms like artificial intelligence, machine learning, and deep learning, and so on. Right? These are different. This basically involves a little bit more complicated mathematical algorithms and more complicated infrastructure that's needed to process these algorithms. Right? Now, I'm talking about data. In order to handle data, you need a system. And when the data is large, this itself is a separate field where how do you handle data? How do you provide data where it's needed, and how do you handle the infrastructure? How do you make sure that the lag is less, and so on? All of that comes under the topic called data engineering, right? When people talk about big data per se, a lot of the discussion is around the data engineering aspect of it, right? The sort of the cool kid in the block is this AI area, which involves mathematical algorithms to try understand patterns in the data, right? But let me first start off by talking about this aspect of it, which is mostly traditional data analysis, right? This traditional data analysis involves understanding of probability and statistics, right? Typically, you have some Excel spreadsheet like this, and you have multiple columns of data. You look at a given column data in this particular given column, and you are trying to understand and summarize what that data is there, right? For example, you might have a spreadsheet like that with, for example, students in a class, right? So you have name of the student, and over here you have the score in science, and score in math, and score in English, and so on and so forth. And now you can look at this score in science and you analyze and say that what is the average score in science, and what is the lowest score in science, and what was the maximum score in science, right? What percentage of people got above 50%? That kind of analysis is typically what we call as data analysis, right? This is something that we learned in middle school. This kind of data analysis actually, even though it's simple, it can be very, very powerful when it's used by someone with domain knowledge, right? People with domain knowledge can take this simple data analysis and try to do all kinds of magic. And I will show one of those magic in a bit, in the very next slide, right? What people do often is they use this idea to do anomaly and outlier detection, right? So people might look at this data and say that, I can see that, okay, here is a particular student who seems to have, failed in all of these subjects, but in this one particular subject, they have done, right? And now you start to think that, okay, the performance in that particular area is an anomaly, or an outlier. And often you need that raises questions which need to be answered. Right. In the case of a student, of course, it might be that the student is particularly good in science, but not in other areas. But it often raises a question, and that question needs to be answered. This is exactly how credit card companies often detect whether there is a fraud or not. Many of you might have tried charging your credit card or a debit card in some particular shop, and suddenly the transaction gets denied, and a call comes, and the customer service person calls you and asks you, okay, did you actually do this particular transaction, right? Or is it a fraudulent transaction? The set of techniques that are being used in the backend is anomaly detection or outlier detection algorithms, right? And it often involves just basic understanding of probability and statistics, nothing more complicated, right? Now, what people do who are doing these data analysis is that they often apply these analytical techniques. And then the most important part is to be able to visualize the results of your analysis and communicate to your business. When people learn data analytics, when you come in and join any particular institute to learn data sciences, this is a key aspect they actually teach you. They teach you not just how to do the math, right? They also teach you how do you visualize the data and how do you communicate to the business, right? The math piece of it is something that we learned in high school or in middle school, actually. But the biggest part is being able to communicate effectively to the business, right? And I'll come back and connect this important point a little bit later when we finish the task. But I want to give an example of this kind of data analysis, right? Not machine learning, right? Simple Excel spreadsheet kind of analysis. And we'll talk about what kind of magic can be done with just Excel kind of analysis, right? So the case study that I want to talk about is on election fraud detection, right? I do not want to talk about India at all. It's often controversial, gets into politics, people get upset and so on and so forth. But I hope none of us will get upset if I start talking about Russian election. So Russia had this election in 2018, and well before the election happened, universally it was expected that Vladimir Putin is going to win, right? It was universally expected he was going to win, is because we all know he was a strong man, and before the election, the leading opponents, he put them in jail, right? So this is not a country that is, particularly known for democracy, and we being in India can say this, right? We are the largest democracy. We have had a longest stretch of democracy in the world. Every single country comes to India to study how elections are conducted, so on, right? This in Russia, when the election results were announced, it was not a big surprise to anyone. Vladimir Putin won with a massive majority, right? Now, when the election, before the election results were even came, Reuters, one of the news agencies, which was reporting actively on election, prior to election and during election, was telling that there was widespread fraud all around in Russia. Now, they were not questioning the results of the election per se. They were just reporting that there were widespread fraud. What kind of fraud am I talking about? Well, one of the reporters who was there, who was on the spot of the election, they were standing in near one of the polling booths, and they were waiting outside the polling booth, and they were counting the number of people who were entering into the polling, right? So you had a clicker in the hand, and as each person walks in, you click, right? And you say that, okay, this particular polling booth, there were 16,000 people who entered into vote. Now the results came, and when the counting started coming, and the organization that counts votes, their equivalent of their election commission, came back and said that, oh, Putin won by 18,000 votes. This reporter was puzzled. only 16,000 people went inside. How is it possible that Putin won with 18,000 votes, right? And there were these kinds of reports, right? So they were, saying that, this just makes no sense at all. That, clearly there is kind of fraud happening. Now, what happened with Russian media is that Russian media is saying that, started saying that, what, these are Western organizations. These Western organizations are necessarily going to say that there is fraud in our election, right? Just like when the US had elections, the US was reporting that, oh, Russia interfered in the election, and so on and so forth. And there were news articles running in Russia saying that the election that was happening in the US was a fake election, right? So when Reuters said that the Russian election was fake, obviously they didn't pay much attention to it. They said, of course, you are a Western news group, and that's exactly what you're going to say, right? Now, the question is this: is there a way we can just look at the data and tell whether election was actually fraudulent or whether the election was a real election, right? And if data can speak, then there's nothing like that, right? So what data scientists do is exactly this, which basically when the elections happen, they get the data from every single polling booth, and they start analyzing the data, right? Now, one of the things that sort of indicates, there are lots of hints that are often there when numbers are being manipulated, right? Now, let me ask you this thing. I'm assuming all of you know what this term means, right? Turnout percentage. Well, what is turnout percentage? Well, let us say a particular constituency has 25,324 registered voters, right? These are the number of registered voters. And let us say the number of people who actually showed up for election to vote is 16,223. These are the number of people who actually voted, right? So when we talk about turnout percentage, this number is 16,223 divided by 25,324. And one can do the math, and you write out this number. I don't have a calculator with me in hand, but let me go ahead and make up a number. I hope you'll forgive me if that doesn't turn out to be the right one. So let's say this is 65.32%, right? This is the way we compute turnout percentages. Now, what people found was that many of the constituencies, the turnout percentage was exactly an integer. So when you compute a turnout, this is some particular large 5-digit number, this is another large 5-digit number, you divide these two numbers, what you get is some fraction. Now, if you had to make up the voting population, right? If you want to make up numbers, provide fake ballots, what would you do? You would say that, oh, you know what? Let's make sure that this particular constituency gets 82% votes, right? Now, this is a number that is often some pre-decided by a guy who wants to rig the election, right? And the way they come up with this numbers is typically an integer number. So from this integer number, then they will say, what should be the implied number of people who voted? Now, what they actually found was many of the constituencies actually had integer turnout values instead of what you expect to be a fractional turnout values, right? That raises marginal amount of suspicion. But you might argue that, that is coincidence. That doesn't in any way tell that there was actually fraud happening in the election, right? Reasonable point that it may be just coincidence. Is there better proof that fraud actually happened in an election, right? So here is, for example, data that I got from one of the elections. So I do consulting work, and a couple of years back for the Indian election as well, I had consulted, did data analysis for one of the political parties. Now, and because of that, I have data from a couple of states. In this data that I'm showing you is data from Gujarat, right? Let me explain to you what is the data that you are seeing, right? Now, in every single constituency, every single poll booth, rather, not constituencies, every single poll booth, we have a voter list, number of people who are supposed to come there to vote, right? And you can compute how many people actually came to vote. And that is the percentage, that is the turnout percentage we talk about, right? So what we did is we looked at data from all the polling booths in Gujarat, right? So polling booth number 1, 2, 3, 4, you take all of the polling booths, and we say that in polling booth 1, 55% of the people, 55.1% of the people showed up. In polling booth 2, 75.3% of the people showed up, and so on and so forth. I take this data, this polling data from the polling booth, and I'm going to plot a histogram. And I'm assuming most of you remember what histogram is from your high school days, right? Histogram is essentially a frequency chart. It says that the number of polling booths where people which had turnout between 60 to 65% is 165, right? And number of polling booths where they were over between 80 to 85% is about 25 polling booths, so on and so forth. That is this histogram. Now, one feature that you should notice about the histogram is that it has a bell-shaped curve, right? Or a Gaussian curve. People call it as a Gaussian distribution or normal distribution. These are all ideas that you guys have learned already in high school, right? Bell-shaped distribution. In fact, most of us are familiar with this because when we get graded on in our college, the way grades are given is the examiner looks at all the scores and then plots the scores in a histogram. And what you find is naturally a bell-shaped distribution. What does it mean? It means that there are very few number of people who have gotten very high score in the class, and there are very few people who have gotten very low score. Most of the people will be in the middle, somewhere in the middle. That's what this histogram is. Here, I'm plotting the election turnout in as a histogram. And it's not much of a surprise that you get a bell-shaped curve. In this case, the meaning of the bell-shaped curve is that there are very few constituencies where there was very high voting percentage, right? And there are very few constituencies where there was almost 10% or less voting percentage. Most polling booths had percentages, the turnout percentage, somewhere between 30 to 70%, right? That is what this data tells. In any election, when you look at it, look at the data of the turnout, you expect a Gaussian or a bell-shaped distribution. Now, let's look at another number. Here are these polling booths, I said, and this is the turnout values. Right? I'm going to, for the same, for every single polling booth, I'm so sorry, my handwriting is bad, and so everything is turning out to be tilted. I am going to write here how many people voted for winner, voted for the eventual winner, right? What percentage of people voted for eventual winner? Well, it turns out often that, there are some constituencies which voted for the person who eventually became the prime minister. There are other constituencies, some might have voted for the opposition party, right? So the one, this particular constituencies, if let's say majority of them voted for the eventual winner, then the number will be say 73%. It means that 73% actually voted for the final prime minister or the final president. When this number is 32%, it means that from this particular polling booth, majority of them voted for the opposition party person, not for the winner, right? And so you can look at this data, and this is again data that's available in an Excel sheet. You can again plot this in a histogram. And you know what the shape of that will look like? Well, the shape of that will again look like a like a bell-shaped curve. What does that mean? Well, what it will mean that there will be there are very few constituencies which voted entirely for the eventual winner. In this case, Putin. Right? There are very few constituencies which voted almost entirely for Putin. Even in the constituencies which Putin won, some of them would have voted for the opposition party. Right? So, and there are going to be some constituencies where the opposition party person won. Right? But there will be very few of them. Right? So you will expect a curve even for the percentage of people who voted for the winner. That curve will also be a Gaussian distribution. Now, what I'm going to do is this. I'm going to draw the graph. I'm going to draw the data. Let me clear the screen. It's an easy way to clear the screen. I apologize. Yes, that's the best way to clear the screen. Yeah. So now what we are going to do is I have two columns of data. One column of data. So I have two columns of data. One data is the turnout percentage. The other data I have is the percentage who voted for the winner. These two columns I'm plotting. Right? What I'm going to do is this one I plotted as a histogram, and that histogram looked like this. This one I will again plot in a histogram, and that will be another histogram that looks like this. Now, what we can do is we can plot them on a three-dimensional graph. On the x-axis, I can plot the turnout. On the y-axis, I can plot the percentage who voted for the winner. What I will get is one histogram like this. And on this axis, I will get another histogram. And if you want to imagine a 3D picture, what you would see is basically a mountain in the middle, and it sort of drops off on the side. That is the kind of 3D graph you will get. Right? Now, we can visualize that mountain as a heat map. We can look at the mountain from the top and find out where are the high peaks of the mountain and where are the valleys in the mountain. When we look at it, the graph sort of looks like this. Let me start off by discussing Romania first. Now, what does this graph say? So on the x-axis on this side, I'm plotting the turnout. So what I'm seeing is a massive peak here, and the sides not peak. So it's actually showing a bell-shaped curve. That's the bell-shaped curve that you're seeing. On this axis, I'm plotting percentage of people who voted for the winner. And even on that slice, you are seeing a bell-shaped curve on that side, that axis there. Right? This is what one expects. A bell-shaped curve is what one expects. Right? Most countries, when you plot the histogram and the heat map from it, you will see a bright spot in the middle, and some sides you see some light colors. This is what you expect when the election is a clean election. But you see that that's not the pattern in all countries. Oh, here is Russia. What happened in Russia? In Russia, there was this peak here that is there in other countries. But you see this, there are in the corner, there seems to be another peak on the far out in the corner. What is the meaning of that peak? The meaning of that peak is that, oh, there are some few constituencies where 100% turnout happened. And that constituency, not only 100% turnout happened, they all voted for the winner. They all voted for Putin. Right? When you see a separate peak like that, that is an indication of elections. You notice that kind of elections in both Russia and in Uganda, you see that kind of. I didn't have to be on the ground at all. All I had to do is look at the data, plot the data in Excel sheets, and I can figure out where fraud happened, where fraud did not happen. In India, you can plot this and you will see that it's actually, there is no fraud. Right? There might have been one or two constituencies where there's booth capturing and things like that happen, but nothing, no massive fraud or anything at all. Which is why, right, whenever Indian election happens, people accept the results. Peaceful transfer of power happens right away. right? But that's not necessarily the case in some of these other countries. The intent was of this case study was just to show that data analysis does not often require fancy algorithms, fancy math, or fancy computational tool. You can do this on Excel. And this is an example of kind of analysis that people previously learned under the topic called business analytics or business analysis, right? Typically Excel-based analysis involving some kind of visualization tool and so on. So one might ask then, what is machine learning, right? What are the key area of when people join a data science program, they want to learn, they're coming because they want to learn machine learning and data analytics, right? So I want to distinguish between what is machine learning and what is traditional programming. When you're writing a traditional program, here is a simple program. All of you are familiar with this. Print hello. Right? So all it does is it will print the statement hello world. This is an example of a simple program. You'd say, well, there is no decision actually being involved. This is not a program per se. Yeah, I'd say, yeah, fair enough. Let me add some more lines to it. Okay. Print. What is your name? I'll ask you to print what is your name. And then it says that now you read the name from the screen. And then you say that print back hello name. Now you're interacting with the data that's around. And based on that data, you're printing something. Right? So there's some amount of decision making is there. This is what happens in traditional programming. A more complicated version of traditional program, the one that we deal with in a business situation is, for example, a bank wants to approve loans, right? Or process loans, right? The bank loan processing process is typically like this. When somebody submits a bank loan application, you submit a massive 20-page application or 30-page application, giving your entire life history, not just your life history, your neighbor's life history, and the neighbor's life history, everything. What the bank does with this kind of information is they start looking at, they process the loan in a very systematic way, right? They might have rules something like this. Turn to page number 15. Look at information number 25. That lists the salary of the person. Take the salary. Then turn to page number 11. Column number 5. That has the loan amount. Take the loan amount, divide by the salary. If that number is greater than 1, you reject the loan. Otherwise, you move on to the next step. Next, you look at how many dependents a person has. Take that number of dependents, take the salary, divide by the number of dependents. If that number is less than or greater than something, then you approve the loan, right? Something like that. This is what this set of if-else then statements can be coded up in a traditional program. Right? In a traditional programming, what we do is we provide a set of data for prediction. We provide a set of data for prediction. You have a set of rules and you process it through the program. And out comes the answer for whether you need to approve the loan for this person or not. This is a traditional rules-based engine. This is not machine learning, right? This in recent days, it goes by a much more, this is traditional programming, rules-based programming, but it goes by a more sexier name these days. They call it as RPA, robotic process automation, right? So what is machine learning? Well, machine learning is a different way of looking at the data. What you do is you go back in history and you find out, get information about all the people who applied for the loan. And you look at whether they paid this loan fully or not, whether they defaulted on the loan, right? You take this data and you supply it to the machine and you ask the machine, tell me what is the information that is the relationship between this information, the information about the loan applicant, and about whether they are actually going to pay back the loan, right? When a machine figures out this relationship, we call it as machine learning. This is the main difference between traditional programming versus machine learning. This was traditional programming. In machine learning, what happens is we supply the data, and the desired answers with that. And from the output comes the rules which are relationships between the predictor and the desired answer, right? This is the this is the area of machine learning. In the area of machine learning, there are multiple machine learning paradigms that are there. There's what we call as supervised learning. Supervised learning is an example that I talked about, where you provide the data and you say that here is a desired output that I expect. Now tell me the pattern between the data, the predictor data and the desired output. And this will allow me to generate rules on for who are the people I can approve rules. What kind of people can I approve rules to, right? That comes under the topic called supervised learning. People who are already familiar with data science know this, and there are sub branches over here. There is in supervised learning called classification and regression. There is another branch of another paradigm of machine learning called unsupervised learning. What happens in unsupervised learning is the data is given, and from the data, you without a desired answer, a set of loan applicants are given, right? And you are asked to analyze a question. Tell me what kind of people apply for loan into my bank. That kind of analysis is typically done on unsupervised learning, right? I have examples of it. I'm realizing, unfortunately, I'm running out of time. And there is one more paradigm of machine learning called reinforcement learning. But what I want to do is I have just 10 more minutes left, and I already see some people raising hands for questions. I will get to your questions in 5 minutes, but just give me 5 minutes to walk through an example of a case study of how the idea of supervised learning and unsupervised learning jointly together is used in a case of a retail industry, right? The specific case study that I want to talk about is about one of these large basket retailers that are in US. The largest retailer in the world is Walmart, right? The number of goods that they have and the number of store locations that they have, they are by far the market leader. Of course, in the online world, it's Amazon, but in the offline world, Walmart is the market leader when it comes to retail. It has competitors in the US, or I should say it had competitors in the US. The two big competitors it had are Target and Kmart. Both of these were also this big store retailers, big chain store retailers. Just like Walmart, they also had several locations. But the thing is, Walmart actually expanded much faster than what these two guys, Target and Kmart, could expand. And they very quickly became a number one. Now, these two guys, Target and Kmart, were fighting out among each other as to who can be the number two person. Okay. The case study that I'm going to talk about is about specifically about Target and about this fight to death that happened between this company Target and Kmart, right? Now, all of these companies are trying to steal customers from each other, right? If you want to grow, obviously the number of customers are finite. If a retail company wants to grow, you got to steal customers from some other store. The thing is, we as customers, unfortunately, are creatures of habit, right? I find myself always walking to the same store for buying clothes that I want, right? I realized that I got into that particular habit of going to this one particular store whose name I won't advertise here. I don't want to give them free advertising, mostly because it was close to my office. So whenever I needed to buy something, I just walk into that particular store and buy stuff. Right? So we are often creatures of habit. We don't necessarily always go to shops which are at the lowest price, right? We might think that we are looking for good deals and so on, so forth, but we are very much creatures of habit. And it's very hard to break a customer's habit. Now, when Kmart wants to steal customers from Walmart or Target, they need to break a customer's habit. right? There is a customer who's always going into that particular store. They need to break that habit and try to pull them away back into your store, right? And breaking this customer's habit is a hard thing. That's we know that from our looking at behaviors of people. There are, however, times when people are willing to break their habit. When do we break our shopping habit? Well, one time when we break a habit is when we move to a new city or a neighborhood. Right? You go to a new city, the old store that you used to go to is no longer convenient. Obviously, at that time now, you're willing to explore the market and see who are the new shop, which are the new places where I can buy something. You know what? These big store retailers know how to make use of this. This is a time people are willing to break habits, right? And they know how to break use of this. In the US, when I'm moving from one apartment to another apartment, I will go to the post office and I will give an address change form. When I give the address change form, I'm saying that, what the post office does is they take the address change form, and for the next 6 months, whatever mail comes to my old address, for free, they will send it to the new address. They'll redirect it to my new address. Right? This is a free service, US Postal Service does. But when I'm filling the address change form and I give it to the post office accepts it. And along with it, they give me a bunch of coupons or offers. Why? These are all offers from these big store companies. These big store companies know that this is the time they can change my habit and they can get me to enter into a new store. So this is the time they give these coupons. Another time when we are all willing to change habit is when an unfortunate event happens in our life, like a loss of job. But the big store retailers do not try to target these customers, because when somebody loses a job, obviously they don't have enough capital, they don't have enough money to spend, so they're not interested in that set of customer. But the other tragic event that happens in most people's life, which is marriage, this is something where big store retailers are willing to exploit. In US, as strange as it might sound, in order to get married, you need to first go and get a license. You need to first go and register yourself in the office and get a license. Once you have the license, you need to wait for 1 week before you can get married. When you go to the government office and to get a marriage license, you fill out the form for marriage license. What do they give you? They give you a bunch of an envelope with coupons and offers, because they know that this is a time they can change your shopping habit, and this is the time they can get it. Another time we are all willing to change habits is when there is a big change that happens in our life, when a birth of child happens. This, again, when a birth of child happens, we are all willing to change our habits. And you go to the office to register the child's birth. Along with when you're filling the form, they also give you the coupons. Now, each one of these cases is an example where companies use this particular moment in life to advertise and change your habit. But the thing is, this is an open secret. Everybody knows about this. Everybody knows that you are willing to change your habit when there is a birth of child. So everybody advertises to you at that particular time. So there is no competitive advantage. Now, what Target realized is that these kinds of times, there is no competitive advantage. Now, in early 2002, they realized that if I can figure out ahead of time that you are a customer is going to have a baby in 3 months, then if I start advertising to them early on, much before these other guys find you and advertise, then you are likely to change habit before the event actually happens, right? So the goal is, can you identify when a customer is pregnant so that we can start sending ads during their second trimester? How do you get data for this? The thing is, if obviously when you see a person and the person is 8 months pregnant, you know that that person is pregnant. But the size of the stomach alone is not indication of pregnancy. If you see me in real life, you'd see a nice big belly. I'm not pregnant. I'm not delivering anytime soon. The question often is, can I figure out if someone is pregnant looking at their shopping habits? Now, Target, what they have is the entire shopping history of everyone who's transacted there. You go to the shop and you buy something, you go to the billing section and you put it. The first thing they ask you is they ask your phone number. You give them the phone number and then they enter all the products that you have bought. This is going into some particular big database. The question they have is, I know what are the things you have purchased. Looking at the things you have purchased, can I figure out that you are likely to have a child 3 months from now? If I can figure that one out, then I can start advertising for you ahead of time, and I can advertise to you before Walmart advertises to you or Kmart advertises you, and I can actually get a new customer. That is the key idea. The thing is, it is possible. We do know that it is possible to recognize expectant mothers, because expectant mothers buy prenatal vitamins or larger clothes and creams and things like that. So definitely you can identify expectant mothers. If you capture them at the right stage, you have trapped them as a customer for years and years and years, right? So the question is, how do you do that? How do you get data for this? Turns out that in the US, people register in order to, when they're going to have a baby, they register for a gift registry. And that particular database actually tells when the person is going to have baby. You go and say voluntarily, I'm going to have a baby in March. I'm going to put these are the items I would like as gifts in case my friends wanted to give me any gifts. What Target did is they took the data from this gift registry and analyzed who are these expectant mothers, what are the things they purchased 3 months prior. And from there, they found patterns in the data. And from the patterns, they found that there are things like lotions people buy larger clothes, people buy vitamins when they are pregnant, right? And using this, they were able to build a model, right? And they found a set of 25 products which analyzed together allowed them to give a pregnancy prediction score. And in fact, Target got so good at it that they were able to make a statement like this. Look at the statement. Remarkable information they can tell. Jenny Ward, who's 23, lives in Atlanta, and in March bought cocoa butter lotion, a purse large enough to double as diaper bag, zinc and magnesium supplements, and bright blue bra. These are the things that she bought. There is an 87% chance that she is pregnant and that her delivery date is sometime in late August, right? They were able to figure it out just by this data. Once they were able to figure it out, they started advertising to these people, and they were even able to figure out whether emails are better or should I give them printed coupons, right? All kinds of information they were able to figure out. They even able to figure out how soon should coupons be sent, because you don't want to send it too ahead of time because they'll forget your store. You need to send it at the right amount of time. Without any exaggeration, I have to say this kind of analytics, which started much before the term data analytics itself was popular, was the primary reason why Kmart went bankrupt. One of the competitors of Target, they went bankrupt. Retail is one of the biggest places where data sciences and data analytics are used. I did intend to talk about one more case study, but I see that I've actually already run over my time. So let me stop here and ask if there are any questions that I can address. Hello.
Yes, sir. So we see that Sharath wants to ask a question. Sharath?
Good evening, sir.
Good evening, sir.
Sir, I'm Sharath. So I'm stepping into the data science field, and your class is like a huge inflow of information to us. We are very thankful to you. So my question is that, so regarding the election data, so so I have one inference from this. So means, can you just elaborate? Means like, so a normal distribution curve on election visualization graph is an indication of fair election. So if the graph pattern is normal distribution, it is a fair election.
Very good question. Very good question. So the only statement I made was if you have a fraudulent election, then you will. Let me say this. Okay, when you see a non-normal distribution, that implies fraud. Okay. Now, there is different kinds of fraud that can happen. Not all fraud will show up as a non-normal distribution. I just showed you one method of detecting fraud, but there are other methods of detecting fraud. All of them are related to this idea of anomaly detection. Right? Anomaly detection is this thing. I showed you one way of doing it, which is looking at the normal distribution. But there are multiple methods people use this together, and from there to offer some proof that this is likely to have fraudulent, likely to have been a fraudulent action. Yeah. I see another someone else raised hand too. Please speak up, or you can type in the chat as well if there is a question.
Sir, a second question also, then I will wind up. Sir,
Sure.
So what's the fate of Kmart and Target now?
So Kmart went bankrupt. Target is still alive and it's doing reasonably well. It went down, but it's picked up quite a bit again. Now it's the story that I was talking about was from 2002, when other companies did not really realize that this kind of analytics was possible. And there's a lot of an interesting epilogue to that particular story as well. But what now what's happening is almost every single company does this kind of analytics behind. And if you do not do analytics, then your survival becomes an issue, or becomes a question. Right? I recently, a friend of mine was talking about one of the stores in Hyderabad, where they went shopping, a grocery store, and they realized that the very first aisle of the store is now being stocked with a different item than what it used to be even prior to the pandemic. And when you see this kind of restocking that's happening, it's not by accident. There is a strong data support, and there's very smart reasons why they do this kind of shifting that's happening, and that's all done through data analysis, data analytics.
So Walmart is still the biggest retailers in America,
Correct.
right? US.
Correct. Yes.
Thank you, sir.
Yeah. Anyone else? I'm sorry, I did see a couple of hands going up when I was talking, but I didn't pause. I'm not sure if they dropped out already or not.
So, sir, one more question. Means like you mentioned about cyber physical system in means 4.0 generation. So
Correct.
I have a doubt. Means like what's the connection between physical systems and our data analysis? So when you are showing in the graphs.
Right. So the thing is, I cannot emphasize enough the number of domains where it's actually being used. Right? It's actually it's no longer this particular domain is leading in data analytics and so on. It is not just that. It's actually used everywhere. So in each one of them, it's a mixture of your traditional way of having data and versus this modern way of having data. Things are getting mixed, and from there you start doing these analytics together. Right? The talk of the town is no longer specialization or being in a narrow specialization. Instead, being able to do a lot of things and bring data together from multiple places and do the analysis. That is the kind of implication, right? You mix data from multiple sources, multiple streams. All of us carry data here. We have watches which measures our heart rate, right? So you use information from physical data along with some of these other data that systems are already computing on how I work out and so on. From there, can I predict, possibility of heart attack or possibility of any illness and things like that. Right? Mixing of data from data sources.
Thank you, sir.
Yeah.
So we have one question from Rohit.
Sure.
So he has kept it in the Q&A. So he says, sir, can you please take a few minutes to give multiple short examples of get results that the business find interesting?
So one example, quick one. is this. IBM actually, one of the reasons IBM is very famous for is this mainframe computers. Right? These guys, they built one massive supercomputer, and this particular supercomputer was it got a lot of popular press because they used the supercomputer to actually play chess. This was the first computer that beat a human, Kasparov, in chess sometime in 90s, and this was a huge big deal at that time. But the reason why IBM built these big supercomputers is because they were also developing the services business where they were not just selling data, selling these computers. They were doing this consulting business where they were taking consulting projects from companies, and from that consulting projects, run it on their machines, have the expert data analytics people there, and then provide them insights onto for companies. They had approached Walmart, and they got Walmart's transaction level data. I talked about transaction level data at Target. These guys had went and approached from Walmart, and Walmart, there is like millions of transactions happening every single day, right? You have a huge database, and obviously you need a supercomputer to put all of this data in and do this analysis. They took this data, and they said, we are going to analyze the data and try to find patterns in the data that are there that you might not have known before, right? So this is an example of unsupervised learning. Supervised learning is where you have a target class. You're trying to predict whether somebody is pregnant or not. That's an example of supervised learning. In this case, a data is just given, and the question is, can you find interesting patterns in the data? So IBM took this transaction level data and ran an unsupervised learning algorithm. This is called as an association rules algorithm or data mining, and tried to find out patterns in the data. And they came back and they got a whole bunch of patterns, interesting patterns. But many of these patterns were known patterns. For example, around the time of school openings, a customer who buys notebooks are also likely to buy pencils and erasers. Right? Of course, that's clear, right? When the school opening is happening, so you'd buy, you're going to do back to school shopping, you'll buy all of these items together. Right? The Walmart executives said that, yeah, I know about this pattern, right? And IBM came back and they were giving a bunch of these patterns. They said that when this item was bought, there's a high likelihood some other item is also bought, right? An example of this particular pattern, which Walmart found very interesting, was this. On Friday evenings, well, we are on a Friday evening. On Friday evening, men between the age of 25 to 45, when they come into the store to buy milk, they also end up buying beer, right? The moment the Walmart executives heard the pattern, they said, oh, that totally makes sense. I didn't know about this, but it totally makes sense. Here is a person who's anyway running an errand. They're coming into the store and they're buying milk, and they end up buying beer or something. So once this pattern was found, they communicated to the Walmart executives, and then they asked, Walmart said, you know what, I can totally make use of the pattern. So I have a question for you, the person who asked the question. How do you make use of this pattern? Suppose you are an executive, you know that you have been told by this IBM supercomputing algorithm that a person who comes in to buy milk, on Friday evening, they also buy beer. How will you make use of the pattern? Rohit. I see Rohit raising a hand. Can you type in your answer?
Rohit,
well,
you
too much. Unfortunately, we are late, right? So let me quickly this thing. So one possibility might be that you want to say that put milk and beer in the same section. Very nice. Rakesh was saying put milk and beer in the same section, which is what most of us would suggest. What Walmart did was exactly opposite. They put milk in one corner of the store and they put beer in another corner of the store. Why? The thing is, they know that the person who's coming to buy milk anyway buys beer. There is no reason to make it easy. Let's make them walk through the store and see if we can sell them more items. Now, this is basically comes from business domain understanding. There's a lot of talk about how when data scientists come, it's going to cut off people from jobs and people are going to lose jobs because machines are going to take over. But no, I don't believe so. It's going to open up the industry because now for someone who understands domain, someone who understands business, you have an additional tool, additional piece of information that is available to you, which now you can actually monetize and make sure that the businesses are moved. And this is exactly what one of the Hyderabad stores had done when they realigned the shelf through data analytics, right? So data and businesses go together, right? This is what is the new development that has happened. Previously, they were just algorithms. But now what we know is that, yes, these algorithms are great. Fortunately, these algorithms have been coded up in Python, and it's very easy to call these algorithms to one-line command. What is really cool that you guys can do is if you have some business understanding, you can use these algorithms and the results from the algorithm to empower your career. You will be a much stronger candidate when you have some amount of business understanding along with this data analytics tool, right? And there'll be nothing to beat you once you have both of them together. So thank you so much for paying attention. I'll stop here. I know I went over time. It's already 15 minutes. My apologies.
Yeah. So we have one more question. If
Sure,
you would
sure.
answer. So,
Sure.
so we have Niharika asking, how do I start working on any use case once I decide on the domain I choose?
Absolutely. Very, very good question, Niharika. This is something I try to give this advice to my students all the time. I know I said I'll wrap up, but so when someone asks me questions, I find myself continuing to talk without stopping. One of the things that I teach at multiple places, and I run a small consulting company, and when I need to hire people, I look at my students, right? I advertise for these jobs, and then my students apply. When I look at the resumes, I get depressed. I find it very, very, very disappointing when I look at these resumes, because what I find is that the students are putting in as their work experience, the projects that they have done over the course of the course of the certificate program, right? You might have had one homework problem, right? The bankruptcy prediction problem. So people do the bankruptcy prediction problem and you add that to the resume. What you don't realize is that all the students are going to do that. And there is your resume will look identical to the resume of somebody else from your batch, right? And that is clearly telling the employer that you haven't taken an extra effort to do something unique, to do something that will make you stand out from others in your class, right? So how do you stand out from others in the class? You know what? There is fantastic resources available on the web. One of them is this website called Kaggle, where there is data science competitions that are happening. There are tons and tons of public data sets available. And you can get in, and these are real world data sets. It's not fictional data sets, right? Real world data sets. You take this data sets and you can try to predict, and you can submit your algorithm over there, and the results of your algorithm over there, and it will rank you. It ranks you in the world, right? So of all the people who have tried this competition, where do you stand, right? And if your rank is anywhere in the thousands, then it's fantastic. It means that you're a very good data scientist. You have a lot of potential. And this Kaggle rank is something you can add into your resume. And you have a Kaggle link, and the employers can come and look at you and see that you have tried these kinds of projects. When they know that you have tried these projects, they know that you are a self-starter. You actually take things in your own hand. You go out and try different problems. This is one thing that you should do, right? If you want to get a job, go and try with real world data. And you can find data from all domains. There is data from stock markets, there's data from cricket, there's data from retail, healthcare, any domain that's of interest, you will find data here. And there is competition that's happening. And of course, there is a possibility that you might actually win a competition. when the prize money is huge, right? One of my students is competing in one of the competitions. He's actually placed 20th right now, and the prize money for that is $100,000, right? That's a massive amount of money for that.